How black holes work. Black holes are the most extreme objects in the universe. They bend space, slow down time, and trap light itself. But what exactly is a black hole, and how does it work? Let's break it down in a simple and clear way. A black hole begins its life as a massive star. Stars exist because gravity pulls matter inward, while nuclear fusion pushes energy outward. For millions or even billions of years, these two forces stay in balance. But when a very large star runs out of fuel, nuclear fusion stops. Gravity wins. The core collapses under its own weight. In a fraction of a second, the star implodes and then explodes as a supernova. What remains is an object so dense that nothing can escape its gravity. This is a black hole. The boundary around a black hole is called the event horizon. It is not a physical surface. It is a point of no return. Once anything crosses the event horizon, it can never come back. Not even light can escape. From the outside, the black hole looks like a dark sphere, but inside, space and time behave in very strange ways. Near a black hole, gravity becomes incredibly strong. Time itself slows down. For an observer far away, someone falling into a black hole would appear to freeze at the edge of the event horizon. Their clock would tick slower and slower. But for the person falling in, everything feels normal. They cross the event horizon in seconds. They never see the outside universe again. At the center of a black hole is something called a singularity. This is where all the mass is squeezed into an infinitely small point. Density becomes infinite. Our current laws of physics stop working here. We do not yet have a complete theory that explains what really happens at the singularity. Black holes are where general relativity and quantum physics collide. As objects fall toward a black hole, gravity stretches them. The side closer to the black hole is pulled much more strongly than the far side. This extreme stretching is called spaghettification. A person would be stretched into a long, thin shape, like a strand of spaghetti. This happens before they ever reach the singularity. Black holes do not roam the universe eating everything. They do not act like cosmic vacuum cleaners. If our sun were replaced by a black hole of the same mass, Earth would continue to orbit almost exactly the same way. A black hole only becomes dangerous when you get very close. Then gravity becomes overwhelming. There are different types of black holes. Stellar black holes form from collapsing stars. Supermassive black holes live at the centers of galaxies. They contain millions or billions of times the mass of the sun. Our own galaxy, the Milky Way, has a supermassive black hole at its center called Sagittarius, a star. It controls the motion of stars around it. Black holes can grow. When gas, dust, and stars fall into them, their mass increases. As matter spirals inward, it forms a glowing disk called an accretion disk. This disk can shine brighter than an entire galaxy. Black holes are not completely black. They slowly lose energy through a process called Hawking radiation. Over incredibly long times, they evaporate. A small black hole would disappear faster. A supermassive black hole would take longer than the age of the universe to vanish. Black holes help shape the universe. They control how galaxies form. They regulate star birth. They reveal the limits of space, time, and reality itself. By studying black holes, we learn not only about the universe, but about the fundamental laws that govern everything. This is how black holes work. A simple story of gravity, space, and time that explains the most mysterious objects in the universe.